Hi, you guys. This is Mrs. Bolin with your notes for 7.1 Properties of Parallelograms. Today we're going to go over the warm-up, the notes, the practice problems, and the solutions to the odd numbered problems. So for the warm-up, here's what you should have had. We're going to combine like terms. So I'm putting a line there because that represents where our equation is exactly evenly balanced. So whatever we do to one side, we have to do to the other side. With the exception of combining like terms, we're not moving anything from one side or the other. We can just put those together. Okay, so if I have two x's and one x, that gives me 3x's plus 180 is equal to 180. And then I want to get the x by itself. So I'm going to get rid of the plus 180 with a minus 180 on both sides. So we have 3x is equal to 0. 0 is a number. So we divide by 3. And our answer is 0. So the value of x that makes that true is when x is equal to 0. For question number 2, this one's a lot easier. I'll draw my line there where my equation is perfectly balanced. I'm going to do the opposite of take away 21, which would be add 21. That's the inverse operation, which cancels it out. And so I have now d is equal to 126. And that is my final answer for question number 2 on the warm-up. Question number 3, what does it mean for two angles to be supplementary? It means that they add up to make 180 degrees. So add up to make 180 degrees. They're supplementary. Okay, question 4, what does it mean for two lines to be parallel? They don't intersect. They do not intersect, or they do not cross. Okay, so here's your notes for today. We're going to go over 5 properties of parallelograms. See if I can zoom out a little bit and get all those in at the same time. So the first one is that opposite sides are parallel, hence the name parallelogram. Okay, so opposite sides would be these sides that don't intersect. Okay, so those two sides are parallel to each other. The other two sides are parallel to each other. So we want to make sure that we specify that the opposite sides are the ones that are parallel. Okay, in this case, we're talking about sides, not angles. So you want to make sure that you're paying attention to all of those important vocabulary words. The next thing we're going to say is that opposite sides, not only are they parallel, but they're also congruent to each other. Congruent is just a fancy word for being equal. We say that two numbers are equal, but we can say that two shapes are congruent to each other. So what that means is that not only is this side parallel to that side, but those two sides are the same size and shape. They have the same measurement. Okay, same thing with these two sides. Those two sides would be equal in measure. So I would say that the opposite sides are congruent to each other. And remember, our fancy symbol there for congruent is an equal sign with the little squiggly on top. It means that shapes are equal to each other. Okay, we know 2 things about the sides, that they're both parallel and they are congruent to each other. We also know that the opposite angles are congruent, this angle and that angle. And the way that we find the opposite ones is we start at 1 and go across the figure. Those 2 are the ones that are opposite from each other. Okay, I could also find this one, and the one that is opposite would be that one over there. Okay, if you go all the way across the parallelogram, those are the opposite angles. Okay, so we know that opposite angles are also congruent to each other, just like opposite sides. What about the angles that are in a row from one to another? So if you connected one angle and you drew it to the other angle and it was on the side, those are consecutive angles, or meaning they're in a row, okay? One right after the other. And they're supplementary. So I know that they add up to make 180 degrees. Okay, so if you connect 2 angles and it's a side, we know it's going to equal 180 degrees. Okay, and then the last thing that we know is that diagonals are bisectors. And what that means is that if I draw from one corner to the next, and I draw from the other side, the other corner to the one right across from it, these lines will chop each other in half. So those two little parts are equal to each other, and these two longer green parts are equal to each other. Okay, so the diagonals chop each other in half. That's what a bisector is. Okay, so diagonals are bisectors. We also know that, consecutive angles are supplementary. And remember, supplementary means 180. Okay, so now we're going to do some practice problems together. So question number 1 here says, identify what parts must be parallel to the given information in order for it to be a parallelogram. So I'm going to start by finding D and L on my figure. So I have D and L. So then I need to think, well, what one has to be parallel to that? Well, that would be from J to Y. This little symbol right here, the little arrows, that just means parallel. So you don't need to write that down when you're writing the letters. It's not like J is greater than Y. It's just the J and the Y. So J and Y. And then we put that little line on top of it to let you know that it represents the line segment between those two endpoints. Okay. Then if I'm looking from L to Y here, and it's asking what has to be parallel to LY in order for this to be a parallelogram? Well, it would be from D to J. So I'm just going to write DJ. And then remember, I put the little bar on top to show you that it is actually the line segment from D to J. Okay, question number 2. If I know that those are opposite sides in a parallelogram, they've told me it's a parallelogram. If I know that they're opposite sides, then I know that they have to be equal to each other. So I'm just going to write this little equation. 3x take away 8 has to be equal to 19 for this to be a parallelogram. Those have to be the same. So I'm going to draw my line. I'm going to solve. I'm going to go plus 8 plus 8. So I have 3x equals 27. And then I'm going to divide by 3, and so x is equal to 9. Final answer there. Okay, same thing for number 3. We're going to look at the opposite sides, and remember, we know that opposite sides are congruent to each other. Okay, so I'm going to look at n and 12. I know that those are equal, so I'm going to write that equation. N equals 12. Okay, well, that one's already solved. So we're done. So I'm just going to draw a little box around that. Okay, now I'm going to look at the other set of opposite sides. So I've got m plus 1 and I have 6. So I'm going to write that out. M plus 1 is equal to 6. There's my little line where my equation is perfectly balanced. And then what I do to one side, I have to do to the other side. I want to get m all by itself. I want to isolate the variable. So the opposite of adding 1 would be subtracting 1. So I'm doing the inverse operation, the opposite, in order to get my letter by itself. So those things cancel each other out. So I have m is equal to 5. All right, and there's our 2 answers for question number 3. Moving on to question number 4. Because I don't need to move my book each time, huh? For question number 4, I realized that I have, if I could go from one angle all the way across to get to the other one, I know that those are opposite angles. And when they're opposite angles, we know that they're equal to each other. So I'm going to set up an equation for that. So I'm going to write 9x plus 21 has to be equal to 120. So I'm going to subtract the 21 on both sides. I have 9x is equal to 99, and x is equal to 11. And that's it for number 4. Let me move my camera just a little bit here. Okay, so for question number 5, we're going to set up 2 different equations because we have 2 different variables. I'm going to start with the sides. So I know this z minus 8 and the 20. So z minus 8 is equal to 20. And then the next thing I need to do is get the z by itself. So I'm going to go plus 8 on both sides. So I get z is equal to 28. Okay, then I also need to look at the angles. And remember, anytime you can draw from one to the other and it goes across the parallelogram, you know those are opposite angles. So I know that opposite angles are congruent, so I'm going to go ahead and write that out. D minus 21 is equal to 105. And then I'm going to solve that. Plus the 21. So I get D is equal to 126. And I'm done. That's it. Okay, so the math in this section is not super hard, right? This is stuff that we've been doing since the beginning of the school year, but it's just important to remember the different vocabulary, some of those properties, and so it's important to pay attention to the details, because look at this next one, you guys. If I'm looking at these angles, right, they're not outside, it has a degree, so that's going to tell me they're angles, they're inside the parallelogram. If I connect from one to the other, it's not going across the parallelogram, it's on one of the sides. That tells me they're consecutive angles. And I know that consecutive angles are supplementary, which means that they add up to make 180, okay? So I'm gonna start with the first one, 11x take away 8. I'm gonna add the second one, 67, and I know together they make 180. So that's what your equation should look like. I'm gonna draw my line where I'm balanced. On this side, I can combine any like terms. So I'm going to go 67, take away 8. And so I have 11x plus 59 is equal to 180. Then I'm going to subtract the 59 on both sides so that it stays evenly balanced. So I have 11x is equal to 121. I'm going to divide by the 11 on both sides, and I get x is equal to 11. Okay, question number 7, 2 more, then we'll be done with the practice and we'll move on to the homework problems. So for question number 7, again, you're going to look and say, okay, these are inside the parallelogram. So that kind of tells us that they're going to be angles. Even though there's no degrees or anything, they're written on the inside. Okay, whereas remember our sides were written on the outside. So inside, and then if I go from one angle to the other angle, it didn't go across. So that means that they are not opposite angles. That means that they are consecutive angles. When you connect one to the other and it makes one of the sides, consecutive angles all in a row. So then we know that they're supplementary, just like the last one. We know that when I add them together, it makes 180. So I'm going to write 2x plus 65 plus 115 plus x, so that plus that, has to add up and make 180. So I'm going to combine my like terms. I'm going to say, well, I've got 2x and one more x is 3x. 65 and 115 is 180. On this side, I just had 180. So when I subtract that, what's going to happen? I get 3x is equal to 0. And when I divide by the 3, I get x is equal to 0. So that's my answer for that one, just like the warm-up, okay? Question number 8, we actually have 2 different equations here because we have 2 different letters. So that's your indication that you're probably going to have 2 answers. So I'm just going to go alphabetically. So I'm going to look at the C and I'm going to say, well, this and this are 2 equal portions of that diagonal. So I'm going to write out that equation. C plus 5 equals 11, because I know that the diagonals chop each other in half, okay? So C plus 5 equals 11 minus the 5 on both sides. So we get C is equal to 6. Showing your work the right way is just as important as getting the right answer, okay? The right answer is important, but it's also really, really important to show your algebra correctly. Okay, then the next part of my diagonal, well, a different diagonal, next part of my parallelogram is this diagonal got evenly chopped in half. So I can say that D plus 4 is equal to 14. I'm going to subtract 4 on both sides. So I have D is equal to 10, and that is my final answer for that problem. Okay, so we're done with the practice problems, with the notes. Now we're going to go over and to the actual homework problems, and I'm just going to do the odd problems. But if you know how to do the odd problems, you guys should be able to use that work and figure out how to do the even problems. Okay, and then you're going to enter your answers in Canvas, making sure that you take a picture of your work, and you have to have work for every single problem. There's only 10 of them, and I'm going to help you with half of them. Okay. So here is question number 1 on the homework assignment in Canvas. So this says to find the value of each variable in the parallelogram. So we see right here, there's 2 different letters. So that means that we're going to have to put in 2 different answers. So I'm going to start alphabetically with x, y, z. And I know that it's opposite from that 17. So I'm going to write my first equation, which is going to be, oops, sorry about that. My first equation is going to be x plus 3 equals 17 minus the 3 on both sides. So x is equal to 14. Okay, again, the math that we're doing here isn't super hard. We're adding, subtracting, sometimes multiplying or dividing. But what's really important is that you guys understand these properties and then apply your algebra skills to that. Okay, next one, we're going to look at the y, and we know that it's opposite from the 38. So I'm going to say y minus 2 is equal to 38. Add the 2 on both sides, so y is equal to 40. All right, I'm skipping problem 2, but just to help you guys out here, remember that the ones, if you could draw a line from one to the other, those ones are opposite. And so those are going to be equal to each other, okay? The ones that if you, and we're always starting with the value we know. That's why I'm not connecting those two, because those have 2 different letters, okay? But if I look at the value I know and connect it to the different one, remember if I go from here to here, those are on the same side, so they're consecutive, or remember same side interior from a few weeks ago. Those ones I know are going to add together. One plus the other is going to make 180. Okay, so you guys try that on your own and get your answer into Canvas. We're going to go on to question number 3 together here. Okay, for question number 3, I'm going to start with letter A alphabetically, and I realize that that is a side, so it has to be equal to the only other side that we have a value for, and those happen to be opposite, so we know that they're congruent to each other, that their values are equal, their measures. Okay, so A plus 5 is equal to 15. I'm going to subtract 5 on both sides, so A is equal to 10. Okie dokie. And then I'm gonna do B. Well, B is an angle. So I'm gonna go to the other corner, and yep, I went all the way across. So that tells me that they are opposite angles, in which case I know that they're congruent, so I can put that they're equal to each other. So I have 3B is equal to 111. And then I'm gonna divide by B on both sides. Sorry, I wanna get B, so I'm gonna divide by 3 on both sides. Sorry, I misspoke. Divide by the 3. I was trying to get ahead of myself because I'm super excited about what's coming up next. Have you guys ever done short division? Short division is like long division, but way better. So on this side, the 3's cancel. So I don't even need my calculator for this. I don't know the answer, but I can break it up into smaller problems that I do know the answer to. So I'm going to say, well, 3 goes into 11 3 times, right? 3 times 3 is 9. Well, then there's 2 left over. So I'm going to put the 2 together with that 1, and it's going to make 21. Okay, it's kind of like when we're borrowing a little bit, but it's just the remainder. Okay, so I have 2 left over, so I have 21. 3 goes into 21. I know that. That's 7. So I'm going to put the 7 right there. Bam. Didn't even need a calculator for that one. So you're welcome. Just kidding. All right, so that is the answer though. B equals 37. Okay, we are going to skip number 4, but do remember that when you have a diagonal and the other diagonal, they break each other up into equal pieces. So you could just say that equals that and then go ahead and solve that. All right, question number 5 together. Same principle here is we're going to go the S's right now. So that piece is equal to that piece because that diagonal got chopped in half. So I'm going to write out that equation as 3S equals 27. I'm going to divide by 3 on both sides. So S is equal to 9. Now I'm going to do letter T. Oops. Okay, so I have T plus 5 is equal to 19 because I know that diagonal got chopped in half because these diagonals bisect each other. So T plus 5 is equal to 19. So minus the 5 on both sides. So T equals 14. Okay, we're gonna skip number 6, but you know what, you guys? Opposite sides are gonna be equal. Just put an equal sign right there, equals 41, and solve that one, okay? Going on to number 7. Let me adjust that a little bit. Okay, so first we're going to look at M and how it compares to the angle that we know. So those are across from each other, so they're opposite angles. So I know that they're congruent to each other. So 2M equals 70. Divide by 2, divide by 2. So M equals, if you didn't know that was 35, you could use short division again. You could say 2 goes into 7 3 times with 1 left over. 2 goes into 10 5 times, so 35. That will always work. It's a little bit easier when you're just dividing by a single digit. Okay, so that's our first answer. And then look what's across from N, nothing. I don't know anything over there. So you need to say, well, what else do I know? I know that's 70. So how does that connect to the N? Well, they're not across from each other. Darn, that's the easiest kind. But they're in a row. So that means that they have to be supplementary. They're consecutive angles. So I know that N plus 70 is equal to 180. So I'm going to solve that now. Minus 70 on both sides. So I get N is equal to 110. Okay, moving right along. Number 8, we're not going to do, but I just will give you a hint. Start with the X's. Those ones are equal to each other. But look here, we've got an X and a Y. Once you get your answer from X, plug it in here, and then we just get Y equals whatever that number is, okay? So start with X plus 18 is equal to 3X minus 2. That's your starting point. Find X, plug it in, and then that's what Y equals. Okay, question number 9, and then we'll finish up for today. K plus 4 has to be equal to 11, because remember, those are equal pieces of the diagonal. So K plus 4 has to be equal to 11. Draw my line, minus the 4. K is equal to 7. Okay, then I'm going to look at the other diagonal. I should have started with this one. This one didn't even need any work at all, right? M just equals 8. Super easy. Okay, I'm not going to do problem 10, but I'll just give you a little hint real quick before we end. Okay, looking at problem 10, these sides are opposites, right? So I know they're congruent. Saying 2x equals 2x doesn't help me at all, okay? So just ignore those ones, and you're gonna put that this is equal to that, okay? And then you're gonna start there. I like to start by subtracting the smallest x, so I'd go minus 3x on both sides. That just keeps your x's positive. But there's a lot of different first steps for that problem, and you can still end up at the right answer. So that is it for today. That was your recap of lesson 7.1. If I went too fast, which I'm sure I did, make sure that you guys go back and watch any parts of the video, pause it where you need it, make sure you guys get caught up in that. Make sure you enter your answers into Canvas, and make sure you take a picture of your work. So what I've recommended my students to do is get the Canvas app on your phone, because then you can just, as you're working on it in your workbook, you can be entering them in at the same time on your Canvas app, and it's all touchscreen because it's your phone, right? So way easier. Sometimes maybe typing's a little bit harder, but for a lot of them that are multiple choice, that's super easy. And then the other thing that makes it really, really easy is that you can get a good, nice picture when you have it on your phone, and then just click add the file and submit there. So make sure you have a picture for your work. That's how you get a lot of your points, is by showing your work and by having the right answers. Have a great day, and I'll see you tomorrow.